Okay. Hi, everyone. Welcome to the session of today. We're going to be breaking some chains today, if possible. Thank you for coming, and I hope you have a great time. This let's try to be as relaxed as possible. This is going to be very interactive. If you have questions, please feel free to ask or stop me at any time. Turn on, up, like that. Hello, hello. Oh, perfect. So yeah, as I was saying, let's make this as interactive as possible. If you have questions, just let me know and stop me at any time. The goal here is that you guys are the ones that break the chain or implement the tests and run them on the live network. So for that to work, we need to take it slow maybe. And yeah, if any questions, just ask me or my team over here. I'll present them in a bit. But yeah, let's just get started. So yeah, who we are. So we are the execution-spec testing team. So it's comprised by Dan over there. Say hi, Dan.
Hey, everyone.
Spencer, where's Spencer? Hi, over there. Dimitry, and myself. So we're the ones do implementations of the tests for the execution layer, primarily. And we do it and this is what is called the execution-spec-tests. It's a new repository. We have been testing forks for the past year and a half or 2 years maybe, using this Python framework. And we're going to show it off today. And we're going to share with you guys for you to write your own tests today. Yeah, as I said, so we are responsible for coming up with the tests for every fork. There's an extensive amount of tests that have to be written. And to do so, we leverage the power of Python to do that and to make the chain safer before it actually forks into a new version of Ethereum. We also help with tooling. We also do a little bit of Hive. We do verification of the tests. We run the tests on the clients to make sure that they are ready for the next fork, and we help developers also run their tests and our tests to their client. This is the main repository. We're going to be using it a lot. So if you can access it and bookmark this link, it's going to be extensively used throughout the session. Yeah. So yeah, what are we going to be doing today? We're going to set up the testing repository. We're going to add and analyze a very simple test, the simplest one that you can imagine. We're going to run that test that you guys wrote on a live network. We're going to implement a test for a new EIP, which is not tested. And there are no tests anywhere because it hasn't been approved for or CFI'd, how we call it. We're going to find edge cases in that EIP. And hopefully, if you guys find the edge cases, that's even better. And finally, we're going to break the chain. Hopefully, one of you can come up with a test that can break the chain. Otherwise, we're going to end up breaking it anyway. Yeah. All right. So this page here was prepared by Spencer. It contains every link. It contains every piece of information that you need. So if we progress in the slides and you miss something, please just refer to this link and just you can find all the instructions, all the code, everything is there. So yeah, just please take your time, just go into it and bookmark it. And actually, I'm gonna give some time in every slide, so you guys have the time to make sure that you have everything in your laptop and everything is set up. Yeah. Also, the slides are over there, so you can actually see the presentation. You can pick ahead, of course, but if you want to just go with the flow of the workload, that's even better. All right. So the presentation is designed assuming that you don't have basically anything installed. So right now, what I'm going to do is present every single tool that we are going to use to run the tests. Obviously, there are different OSs and different architectures that you guys should have in your laptops. But if you have any trouble installing anything, just let me or anyone in the team know, and they should be able to help you out to install.
Yeah, just put your hand up if you want some help, and we can come over and see how you're getting on.
Yeah. So yeah, the main tool that we're going to use today is the command line. So this is very essential to run any of the commands that we're going to use. This is assuming that you already know how to use or where is it located in your machine. Otherwise, just let one of the team know how to open the command line in your PC. We're going to use a couple of commands, very simple ones: curl, git, Python are some of the ones. You don't have to have Python installed already. It's fine, because one of the steps is to install actually Python. And there's a specific version that it works with the repository. So if you don't have it installed, don't worry. We'll get to that point eventually. Yeah, the tests are coded in Python, but you don't have to know Python. You don't have to be an expert. It's all, we're going to give the examples here. I'm going to explain every single example that we see. Why is the code like that? Everything's going to be explained here. So you don't have to know Python. The advantage of Python is that it's very readable. It's like easy to follow, and anyone can basically just get the gist of what the code is doing. That's why we chose it for the language of our tests. All right, and we're going to use a little tool that is called UB. This is basically like a manager of versions in Python. It's very new, and we just updated our repository to use it. So I think this is going to make it even easier for you guys to install everything that is needed. It should be like a simple command line, and you should be ready to go. Yeah, Git. The only reason that we need Git is just to fetch the code from our repository. So right now, you should most likely already have Git installed in your PC. But if not, you can check in the command line, and you can check using git -- version. If you don't have Git installed, which is unlikely, please refer to these links. This is where you can install it. Raise your hand who doesn't have Git in their computer. All right. If you refer to any of those links, you can just easily install it. Yeah. And we're going to use an IDE. So this is not required. We use VS Code a lot because we have like plugins, and it's basically tailored to use VS Code, the repository, I mean. And you can use whichever IDE you want. Is not required, but this will make your life a little bit simpler. You can get it from there. That's the QR code. Yeah, it's recommended. It's not mandatory. And yeah, there are some extensions that we use in our repository. The main one that I recommend for you guys to install is the Python one. So if you are installing VS Code, you might want to check this one out because it really like highlights and everything, and it corrects some of the code that you're writing. So it's very helpful. It makes things much more straightforward. Yeah, so there's that. And yeah, so yeah, this is the main repository. This is what we're going to use basically for everything today. It contains all of the tools to execute, fill, and generate tests in what we do. So please go ahead and just go up this link and just bookmark it because it's going to be used extensively. Yeah, another thing that we're going to use today, we have a live network. It's a DevNet. It's very small. It's only two nodes. And special thanks to the danceratopz team, which is over there. Thanks for helping us set up this network. The goal is to break it today. This link over here, it contains links to all the tools that we're going to be using to explore the chain. It contains an explorer. It contains the fork visualizer, if that's the name. But yeah, basically that's going to be our goal. And I will go into that link a little bit later in the talk to explain what each of the tools is doing. But yeah, please, if you can, please bookmark also this link. It's going to be also used extensively. And this link should also be in the docs in the doc that I shared at the start of the presentation. And yeah, I think this is the last. Yeah. Finally, if you guys use MetaMask, there is a possibility that you can add this DevNet to your MetaMask. It will simplify sending transactions, but it's not mandatory. Basically, just install MetaMask if you want to send transactions on the network. It's not necessary because our framework it also creates transactions, sends transactions, makes everything for you. But if you want to send other transactions to the network, that's also possible. Here are the characteristics of the network, the name, the RPC URL. All of this is also in the notes that we share at the start of the presentation. So if you want to copy that, just go into the link and just you don't have to manually just type any of that. All right. So yeah, the theory. So there's going to be a little bit of theory, just mainly to explain what we do, how we do it, and go over the repository a little bit. And just explain the parts of the repository, the code, and everything. But I guess I should first ask, are there any questions so far? Yeah. Yeah, of course. I think that link should be the session QR. Yeah, if someone can please try it out and to see if it actually links to the slides, that would be nice. It's a different one. Okay. Mm-hmm. Yep. Great. All right. So yeah, I'm gonna start a little bit with the theory, and I'm gonna go to the actual repository just to explain what we're doing. Basically, and there's gonna be more information later. Dan has a presentation today that's gonna be very awesome. It's gonna go through all the details of the repository. I'm just gonna explain the basics and what do we do with this repository that creates the actual tests. Yeah, so a couple of years ago, basically we were creating tests using YAML, and this is basically what we use to create the test that all the clients, the different clients of Ethereum, consume to verify that they were consensus compliant. What is consensus compliant is whether you are ready or not to be in consensus with another client. If you're not, you're probably going to be forked out of the chain because of an issue. So the test that we write is just to basically make sure that all the clients, if they pass them, they can be with high confidence, they can be guaranteed that they're not going to fork out of the chain. So a couple of years ago, we created this repository. The execution-spec-tests is a new repository. It uses Python. And we use Python to programmatically create those tests. So we're still filling JSON fixtures. The JSON fixtures are consumed by the clients, but now what we have is basically the power of Python, and most importantly the power of pytest. So pytest is the main framework that we use to write basically every single test. It allows us to very programmatically create a lot of different scenarios very quickly. So we have like this single, for example, let's imagine we have one test scenario and we want to create different variations of that. This is super simple with pytest, and I will show you how to do it in a little bit. So it requires, the downside of the execution-spec-test is that we require an implementation of a client to be able to fill the test. And the reason why is that is because we cannot actually execute the state transition. So the state transition is basically when you get a transaction, you fit it into your EVM, it modifies something in the EVM, that is the state transition. We don't have that code inside of execution-spec-tests, but we rely on an external client to do so. And right now, the default client that we use to field test is called EELS, is the execution specs, it's the Python implementation of the Ethereum specification. So this contains all of code, and we use that to field the test, to actually execute this transition. So yeah, apart from that, our repository is capable of filling and verifying tests and running tests against clients or even live networks. Let me just open the link so you can see how is it like. So yeah, from the get-go, we have this link over here. This is the documentation. So this is the repository. We also have a very comprehensive documentation that you can access here. I suggest that when you open the repository, go to the documentation also, and go here in the documentation and open the main version, which is the most up-to-date version of the documentation that we have. But yeah, going back to the repository, it's very simple. We have two paths that are very important. The first one is the source code. Basically, this contains the framework itself, the code of the framework itself. This is used to field tests, and it contains a lot of the logic that we use. For example, it contains one of the most important ones is that we have the definitions of every single fork that has happened in Ethereum, and even the future forks. So if we go, for example, to this file, you can scroll down here, and you will start looking into the actual forks. So the first one, Frontier, happened almost 10 years ago. This contains the definitions that we need for testing. It doesn't contain the logic, but contains what we need to parameterize our tests. And you can scroll down all the way, and you can see that everything is here. The most recent fork that is under development is Prague. This is the one. And it contains definitions for all the, precompiles. It contains definitions for the system contract. There's a lot of new system contracts in Prague. Those are all here because we need to know the addresses to actually test their behavior. Yeah, basically, and also we have an even more in the future fork that is already defined here, which is the one that we're going to be using today because it's the one that is running in the DevNet. That is called Osaka. It's a dummy Osaka because it's not really what's going into Osaka, but it only contains one EIP. Well, it contains UF in here, but that's not what we were going to use today. Yeah, and what else is important here? Yeah. Okay. So another important part is that we define fixtures for our code, for the test. Sorry, this is basically where everything is defined for the output that the client will eventually consume. We have different types of tests here, and the definition for every single type of test is defined in one of each of these files. The main ones is the blockchain type. This is basically just a test that contains a whole blockchain inside of it. It's a fixture, and this is how we output it into a fixture that the client can consume. And what else? The VM is another important part. This is basically how we write the code in here. We don't use Solidity. We use sort of like an internal language, which is very into the EVM code and opcodes. Because Solidity does optimizations when it tries to compile the code, those optimizations hurt the way that we test. So, for example, let's say that we're testing some special opcode, and we write our Solidity code, and then we compile it, and then it optimizes out the opcode for some reason. That is not helpful for us because it can lead us to think that we are failing the test, but instead it was because of Solidity. So what we do here is basically just we define every single opcode that we have, and we use Python magic to basically create bytecode itself. So if you go to this file, you can see all of the opcodes that exist, and even new ones that haven't been implemented yet. Yeah, you can take a look here. Basically, you can construct almost any type of bytecode that can exist, you can use these opcodes here to create it. I'll show you in a bit how they are used in a test. Yeah. Any questions?
Just out of interest, is 3 hours sleep here? Someone called 3 hours sleep? So I just want to say thanks to him because he added all the documentation for the opcodes. He's an EPF fellow in cohort 5.
Yeah.
Do you know him? I don't know.
Yeah. Yeah. So let's go and actually see some of the tests. So everything, yeah, from the main root directory, you can see the tests here. That's basically where every single test that has been created, at least from Shanghai up to now, that's where every single test lives, and it's sorted. It's ordered by directory, which is the name of the fork. So let's say that you want to see what we tested for Shanghai. Let's just go into Shanghai and just see what is in there. You can see 4 EIPs. Those are all the EIPs that affect the EVM behavior for Shanghai. We have only 4 here. This the warm come base, the push 0, which is a new opcode. We have a limit for the init code and the withdrawal. So there are. If you go inside of any of this, let's go into push 0. I think is the easiest one. You can see that we have some files, but the main one is the test file. So if you go in here, you can actually see the Python code that generates the tests for the push 0. And it's well, this one is not that simple, but let me see. Yeah, let me try another example. Let me go to the easiest one, Frontier.
If you go to the
Yeah.
HackMD.
So this is basically the easiest test that we have. So if you go into Frontier opcodes, there's a test for the DUP opcode, which is basically the easiest test that we can do. It's just duplicate something in the stack, in the EVM stack. And yeah, this is how we generate it. This is how a normal test looks like. So basically we have a definition for the function. We have this test DUP, which is the main function that runs and generates these tests. And we have a parameterization. This is one of the best parts of pytest. It allows us to parameterize tests to do the same thing over with different opcodes. For example, in this function, what we do is we parameterize every single DUP code, and then we run basically the same code. I will go into more detail of what each of these lines represents in a little bit. But just to get the main idea is that this is what it looks like. This is what we use, and this is what almost every single test looks like in the Ethereum test repository. Let me see. All right. So back to the presentation. Yeah. So I'm gonna explain briefly because this is really important for anyone that wants to write a test. So the main goal of the test is to do an action in the EVM, and this is composed of 3 parts. Basically, the first part is the setup. We do something previous to the transaction. We set up smart contracts. We set up accounts with Ether that are going to send transactions. We set up balances. We set up nonces. I'll explain what the nonce is a little bit. But basically, the setup is how we lay the grounds of how our test is going to execute. The second part is the action. Basically, the most simple action is the transaction. So once you have set up your smart contracts, once you have set up your accounts, something needs to take a modification into the EVM, and this comes from the transaction. Ethereum is not like event-based. It's more like everything has to come in, every action has to come from a transaction. So this is the part that we use in the test. We basically make a transaction that is going to go potentially into the smart contracts that we already created, and it's going to exercise the action. It's going to modify some code, some storage. It even creates more smart contracts. Normally, is for the simplest tests that are only EVM centric, these are a single transaction, but it can get as complex as many blocks with many transactions each. For today, we're only going to use a single transaction for all the tests. But if you want to see more interesting tests, we can go into one simple example. And yeah, and the last part is the verification. So once you create the smart contracts, you send the transaction to them. You want to see something happen in the EVM, and the most common thing that we check for is the storage. So and let me explain if not everybody knows what the storage is. Basically, it's the permanent memory of the Ethereum. So every contract has the storage, which basically saves information basically forever until it touches it back to zero. But this is what we check when we send the transaction. We check the storage. We also check balances. It's less common, but we do it also. And we also check the code sometimes where we are testing for the deployment of a smart contract. We also check the code. But most importantly, if you want to test something, it has to go into the storage. Even if it's like something that happened in memory, you have to somehow store it into the storage for it to be visible to us in the test. Yeah. Okay. So let's get started. By the way, how's everyone doing on the installs? Has everyone? Anybody has any questions? Just raise your hand. Yep.
Sorry, on the last thing you said. So how does? So you said everything is stored in storage, right? What about the events?
So the events, we don't have tests for. I mean, we do have tests for the events, but most of them. If you want to write the test, what I meant is if you want to write the test, you wouldn't use events. You have to, let's say you test a new opcode that makes I don't know, addition or whatever. You have to end up using the storage to save the output of the action. But the events we don't check them. The way that they are checked is when you do the street transaction, you will have the logs received, you will have the received hash and everything. So that is implicitly tested. But for us to be observable, it has to go into storage, basically. Yeah. All right. Yeah. So let's get started. So the first thing that everyone wants to do should do is we're gonna install this tool that is called EUB. It's gonna allow us to very rapidly run the commands that we need. So that's the command that you need. Please go ahead and just run it to get UV installed. I already have this in my machine installed. Let me open up a command line here. Yeah, so UV is already installed, but yeah, please just go ahead and run this command anywhere in your machine, and you should be able to install UV. Depending on the environment that you're using, it's possible that you might need to run this second command, but it will tell you. So at the end of running UV, you can just run this command if necessary, and you will get the environment set up correctly. So yeah, I can just type anything, and you can see that UV is already installed in my machine. Oh, by the way, this command should also be in the notes. So if you want to just copy paste it, just go to the notes and just copy paste it into your command line. If anyone has any issues, just let us know. All right. The next thing that we're going to do is that we need to fetch the repository. We're going to use the execution-spec-tests, as I said. So this is the command to get it copied to your machine. Run it anywhere where you want to download the repository. Basically, what it will do is just copy from GitHub. It will copy the entire repository into your local machine, so you can start executing stuff. Yeah, and then the second one is just move into the execution-spec-test just to start running stuff inside of there. So I already got this here. So this is what it looks like once you have the run the GitHub clone command. This is clone, yeah. This is what you should end up seeing in your machine after it's executed. It might take a while because the Wi-Fi it's not perfect here, but yeah, just try it out. If anyone has any issues with this command, just let me know. All right. All right. So next thing is these 3 commands. So the first one is just to set up, in case you don't have Python, this is the one that sets up Python for you. So if you run this, it will automatically download the correct version of Python. It will automatically set up everything, and it should be set up for you automatically. So just try that out. Let me just try to run it. Yeah, there you go. It seems like it does nothing, but what you can do. Yep.
I just had a great idea. A few people came in late, so maybe just go back to
perfect.
to Spencer's notes.
Yeah. Yeah. Let me just rewind a little bit. So for the people that just came in, this is the main link that you will be looking at. Just to explain it again, this is a hackmd that contains every single link, every single command, everything that you need is going to be in there. So if you you miss something in the presentation, just go to here, you can see it. And also there's going to be a link to the presentation itself. So if you miss anything, just go in there and just use that link. I'm going to give it a couple time to just wait for everyone.
If you stick around and hunt the bug, then you can collect a POAP. And if you're the lucky participant that breaks the chain, there'll be a special POAP for you too.
Awesome. So yeah, let's go back to the current slide. Yeah. So yeah, after you run the first command, I just run it. So right after that, you should be able to do something like ub run Python and just the version. Basically, just everything. So basically, everything that we run inside of the repository is going to be run using ub. So this is basically what you have to remember to run anything on a repository. ub run is the prefix to everything, basically. And what I'm doing here right now is just I already created the environment, and I said I need Python 3.12, which is the version that is compatible with our framework. I just want to make sure that that is what we're going to see. So let's see if that worked. So yeah, it's going to automatically do a lot of stuff for you. And then you can see that it worked. It's very, very nice to work with the UV because it sets everything up for you. You don't have to install anything, not even Python. So as you can see, UV run automatically runs in the correct environment for you to be able to work rapidly. Yeah. So yeah, the next step is basically performing the initial sync. What sync means is that UV has a log file, which basically every requirement that we need for a framework, it's located inside of this file. And UV sync, what it does is basically, okay, just go ahead and download everything I need in the framework. So let's just do that. It's probably gonna do nothing here because I already did it. Oh yeah, it's gonna download a lot of stuff. It's basically just to prepare for us to run any command in the repository. So it's just gonna take a while. Perfect. So basically, we are ready. We're ready to fill any test. There's basically nothing else that you need to do. It's that simple. And we are going to verify that we actually can run the tests. So this is the main command. This is one of the main commands. We're going to use two commands today. So the first one is the fill command. So filling the tests is one of the first steps where we deliver the tests to, one of the first steps to deliver the tests to the client. And what we're going to do right now is just make a collection. This means inside of pytest is basically just go inside of the test repository and just look for any test that you can find. And if we just go ahead and do that, let's see what happens. it's gonna collect everything. Okay, it's gonna install Sol-C because there are some tests that use Sol-C, so it's gonna automatically install, and then it's gonna collect. And as you can see, it's collecting every single test. So we got around 18,800 tests in our repository. And what you're seeing here is everything. It's basically every single test for every fork that we have. You can be a little bit more selective. Let's run only tests for the fork of Cancun. And it's going to go down a little bit in the number of tests, but basically, yeah. The nice thing about pytest is that, so when you write a test, for example, let's say that I wrote a test for Shanghai, it's going to automatically update it for Cancun, which is the next fork. So you're not only creating tests for now, you're creating tests for the future also. So it's a pretty cool feature that's automatically done for us because of pytest and how we have configured the framework. So yeah, it's working. So let me know if anyone had any trouble running it. Yeah. Let's go ahead. All right. Yeah, the second step is just basically opening Visual Studio Code. So let me just do that. I already have the Visual Studio Code open here. But if you want to open it, just go code and dot, which means open the current folder in Visual Studio Code. Otherwise, you can just go to Visual Studio Code and just open folder, and it's the same thing, basically. Yeah.
How's everyone doing? Do we need to take a moment just to get everyone up to speed, like make sure they're all at the same level? Is anyone having problem cloning the repo or running UV, for example? Has everyone managed to do that? Okay. Perhaps we just take a moment and get everyone up to speed?
Yep. All right. Hey, to the new people arriving, we're basically setting up. I'm just gonna go back to the first slide to. if you want to rewind through the slides or see what we have already done, please just go to the QR in there. It contains all of the information that you will need. We're just waiting on setup. All right, I think we can carry on. Yeah, so let's continue. But we're gonna write the simple test that we can imagine. This is basically gonna be the simplest example, and I'm gonna explain every little bit. So this QR code is a gist. You can go inside and just copy paste the code, and you can paste it in under tests Cancun. That's going to be the folder where you wanted it to be. So let's open up the gist. Basically, just go inside, copy everything, and we're going to create it under test Cancun and just put it there. I'm going to call it test simplest.py. And just paste it here. All right. All right. So I'm gonna go over all of the parts of the tests. So if you want to just pause what you're doing, and I'm gonna just try to explain everything that is happening in this file. All right. So yeah, every single test basically looks like this. We rely a lot on the framework that we have. So that's what is basically most of the imports. If you have used Python before, just an import is basically just a library that you have to import, and most of the important stuff is happening here. Then this line over here. Basically, we can write tests for any of the forks, but some of the tests, which are the newer tests, they only can run in in the newer forks. So in this case, we're going to write a test for Cancun. This is the test. This is what it basically is telling pytest to only fill this test for the Cancun fork. And this is this method definition over here. Yeah, this is basically almost everything that you need. So to define a test in Python, the only thing that you need is create a new file, which in this case we already did. It's called test simplest. And then inside of that file, we're going to create a method. The method is basically a test. In this case, it's going to do a couple of things. The first part is the parameters. So what we need here is we're going to create a state test. The state test is basically just a test with a single transaction to one or more contracts, and that's it. We have another variation that is called blockchain test, which performs tests over an iteration of many blocks with many transactions, but this is the simplest form that we use. Just one transaction, the setup, transaction, output, and that's it. Yeah. And we're also going to use this parameter, which is called the pre. It's basically the pre-state. We're going to use that object to set up everything that we need for our tests. In this case, we're only going to set up two things. And these are what we're seeing here. This is the first thing that we need in basically every single test. We need a smart contract. So this is what's happening here. In this line, we are telling the pre-state to deploy a contract for us. And in this case, you can see here, this is not Solidity. This is something that we created for the EVM testing. Basically, we're going to use two opcodes here. This is one of the most important opcodes that you really need to know when you're writing an AVM test. Basically, it's the store, save to storage, because this is what we are going to observe in the output when we are verifying the tests. So basically, what this test does is just please put a 1 in the store key number 0, and that's it. That's what this smart contract is doing, and then stop execution. That's everything. So what's going to happen when this line of code runs is going to deploy a contract with only this in the bytecode, and that's it. We're going to see a little bit later how the execution happens. We're going to execute this in a live network, and we're going to try to match this to what we see in the blockchain. That's going to be pretty cool. Okay, next, the other part that we need is some EOA. EOA stands for externally owned account. It's basically just a wallet. And we need this because we're going to send a transaction. So the transaction needs funds. And this is exactly what we're doing here. Just create a sender for me with some funds in it. And this is what's going to send the main transaction. Yeah. So the transaction looks like this, very simple. So the destination of the transaction is the contract address, which we just created here. So basically, when we deploy the contract, we get the address to it over here, and that is what we use to craft our transaction. So we send the transaction to that address to exercise this code here. All right? And then also, the second line is here is the sender. So who is going to send the transaction? The account that we just funded over here. So we just reuse that over here. And two more things is basically just how much gas is the transaction going to pay for the execution. In Ethereum, we use the gas, which is the minimal for a transaction is 21,000. But in this case, we're ramping it up a little bit because we're going to use the storage, and that's expensive. So we're going to give it 100,000. And basically, any value that you want to use here is fine. And the last thing that the transaction contains is the value. We're sending one way. It's not one ETH, it's one way. It's 1 to the 1 power of minus 18 ETH sent with the transaction. Yeah, and the last part is gonna be the post state. This is the verification part that we were talking about earlier today. We're gonna verify that something happened in the blockchain, and this is basically check please this address to be this account, and the account should have a balance of 1, which is the value that we're sending, and it has to have a storage of 1 in the 0 key, and that's it. That's everything that we're gonna do to check. Yeah, and the last line is basically just this part over here is the state test is please execute this test with this pre-allocation, this transaction, and this post. That's it. So yeah, let's try to fill that test. It's very easy. So let me show you the command to do it. So yeah, let's just UV run fork Cancun test. There you go. So yeah, this is gonna fill the test. So as you can see, just UV run fill for fork Cancun and just the name of the file I just created. So let's get that and see what happens. There you go. That's it. The test is filled at this point. What does that mean? It doesn't mean that it's executed in a client. It just means that it is now prepared to be executed on a client. So let me just redo that. And just, yeah. Yeah. So now, if you see the files in the folder that you have here, you should see now this fixtures folder. And basically, this contains the test that we just created. Let's go into state test, and you can see that under Cancun and simplest, which is basically what we created, we can see this JSON file. This JSON file is the output that will be consumed by the clients for them to to check their compliance to the consensus. It contains very simple stuff. So you can see the environment is basically how the blockchain looks like at the moment of the transaction is executed. It contains the pre-state. Here is the contract that we created. So this contract over here, this one, it's going to be deployed to this address, and it's going to have this code. So if you see here, you can see the push 1 is over here, right here. The push 0 is over here. And that is the first argument to the E store. Then the 55, that's the S store over here. And finally, you have the stop, which is a 00. And that's it. So the client, when it sees this fixture, it should know that the storage at the start of the execution of the test, it should have this storage at that address. The second account that is created also is the sender of the transaction. So that is this one over here. So the pre-fund EOA, and it's going to be pre-funded with this amount of ETH. This amount of Wei. There's not that much to it. Second, we have the transaction. This is the description that we just created here. So we have this transaction over here, and we have the secret key to the sender, which was generated by this line. So this line not only creates an account in the state, it also gives us the private key, which is going to be used to send the transaction, to sign the actual transaction. And that's what we can see here. You have the address of the sender. You have how much ETH is going to be sent, the data of the transaction, the destination of the transaction, the gas limit, gas price, and all that stuff. And finally, what we're going to see here is the post state. This post state, it means that the state root of the state of the blockchain, it has to match this. Otherwise, you are failing the test. This is a little bit harder to explain because the way that the storage is stored in Ethereum is that you have this big tree that basically just ends up being one hash. But we can see that a little bit clearer in the other. We are generating multiple kinds of tests also. So the one that we are seeing here is the state test, but we also generate blockchain tests automatically, which is basically we have like this entire blockchain in a file. We have the genesis. It's basically the genesis is the first block of the blockchain. But we also have the pre-state and everything. And you can see here more clearly what we expect in the post-it of this fixture. This is not going to be super important, but anyway, I wanted to take a look into how it looks because this is what we end up giving to the clients. But yeah, basically you can see that the end state of what we expect to see, you can see that the contract, the 1000 contract, it has to have a 1 in the 0 key. Otherwise, the test will not pass. So yeah, I think that's it for fixture filling. I want to jump into so you can see the command here that I just used in case you missed it. But yep.
Go for it, man. Sorry, what's your question? Why are there 3 different test fixtures for this one single Python test? So essentially we have different test formats that test on like a different granularity. So we define the test as a state test, which is like a lower granularity than a blockchain test. But from a state test, we have a benefit that we can wrap any so state test is testing on the transaction level. So a single state change, or I mean, you can have multiple transactions, but typically they're just one. But the advantage is if you have a transaction, you can always wrap it in a block in the environment from the block. And so we always generate a blockchain test from that state test. So you get a blockchain test for free. And that's valuable because then we can run the tests in different environments where we can only apply blockchain. Like we can only pass blocks to the client. Yeah. So yeah, sorry. I saw some like requests exceptions, like HTTP errors, like when people were trying to fill. If that happens, just try again. It could just be a bit due to flaky internet because we need to download the version of EELS from the execution specs repo. And if the internet's a little bit flaky, then this might time out. So I think if people I've seen, if they've tried again, it's generally worked. So don't give up.
All right. All right, that is fine and dandy, but we want to see the actual tests run in a live network. So we can do that. And it's a little bit more exciting than just filling the fixture because you're going to see the outcome. So yeah, let's just jump into it and just run the test in a live network. So what is the live network that we're working on? This is the link that I showed earlier. Let's go over there and just see what's happening. How's the network looking like? You will see a couple of links here. So the first is the JSON RPC. This is basically an execution client that is running on the network, and it can receive your transactions. It can send transactions. It can give you the state of the network and everything. But we also have Explorer. We have two Explorers actually, and then you can see here over here. This is basically the state of the transaction right now. Okay, someone's already sending transactions. Perfect. All right. So yeah, this is what you're gonna use when you're sending your test to the network. You are gonna need to come here and see that you're actually sending those transactions to the network. Right now there's a couple ones, but it's gonna get a little bit more heavy the more that we get into the workshop. What else we have? We have Forkmon and Forky. These two tools basically just tell us what's the health of the network. How is it looking? Is every client following the same chain? Have they split? And basically what we want to see here is we have right now a healthy network, but there's two versions of the client running in the network. And one of them is faulty. And I know it's because I faulted myself in there, but the goal is to write the test that is gonna make this go split. All right. So hopefully at the end of the workshop we're gonna end up breaking this. Right now it's looking healthy, so no one has broken anything yet. That's fine. Yeah. What else? Okay. We also have a faucet here. Again, thanks for the EIP DevCon team for all of this. They helped us a lot yesterday to set everything up. They're over there. Thank you. Yeah. And we also have faucet. You can redeem test ETH from here. So if you have an address, just put it in there and just start mining. It's gonna give you some ETH to test. I will wait a little bit because I'm gonna do the execute part myself. I'm gonna show you how to do it, and then you can try it out by yourselves. All right. Yeah. So the first thing that we have to do. We're going to use a command that is called execute. It's pretty new. We just created it a couple of months ago, but it needs an account to send the transactions. So this is a very rudimentary script to create a new private key and an address to it. Basically, it just generates a random number. Please do not use this to store anything valuable for you. This is not safe. This is not crypto safe. This is just for testing purposes. It's going to use the Python random generator, which is basically nothing safe to use to store anything meaningful. All right, but we're going to use it just for testing purposes today. Please just follow the QR code. You can get the gist, and you can copy it to the execution-spec-tests folder. All right, so let's do that. That's right. Obviously, you're gonna see the key that I'm gonna hold. So yeah, please don't troll me and send anything from that. Let's see. Okay, so on the root directory, let's just create touch. Yankee.py. Let's paste everything here. All right. And then just remember to use run to run the command. Yankee. Let's go. Oh, there you go. It's pretty easy. It generated basically a private key. It generated an address. So this is where everything's gonna come from in my test. I'm gonna provide this to the execute command for it to be able to execute the test. But first, we need to take the address. Take the address. Go to the faucet that we have in this link over here. Just go here, paste the address that it gives you, and just start mining. See what happens. Which one? That one? Yeah. Yeah. Okay. So I think we have funds. Let's see. Just claim it. All right. It's processing. And what we can do is just go into the DevNet main page and just go to the Explorer. And we're going to copy paste the address that we gave to the faucet and see if it actually has some money. All right, so it does. We had 100 ETH, which is that amount of USD. I don't think so, but anyway. Yeah, so now we're ready to execute the test. Let's just do that. Let's see. Yeah, basically what I just explained. We're going to use the execute command. You need the faucet to obtain the funds. Here's the link to the faucet, but it's also on the other page that I gave you. If not possible, if you need, for some reason the faucet is not working, just let us know. We can send you funds into to your address. So yeah, also I already checked this in this page. Just all right, go to this page and go to Explorer, paste your address, and you will see the same thing basically. Yeah, let's just do it. All right. So this is the command to execute the test on the live network that we're gonna use to run right now. You need to paste the private key that you generated over here, and then the rest is basically the same. So let's just do that and see what happens. I'm gonna keep an eye on the address that I. Give me a second. So yeah, to make it easier for me, yeah. Perfect. All right. So yeah. So again, UV run execute, then just modify the private key. Just put the key that the script gave you over here. Just copy paste it here, and yeah, let's just hit go and see what happens. And let me explain a little bit of the parameters. So yeah, the parameter over here is basically just how much ETH should the test take from your account. In this case, just take 10 ETH. Which should be sufficient to send the test. The RPC chain ID, which is the DevNet network ID, the fork. This is irrelevant. We're gonna use Osaka eventually, but for testing purposes, it's fine. Whatever you put in there, it can be Cancun or Prague, or we're gonna use Osaka eventually. And then last but not least, the name of the test. So you can see right now that it's already running. And you can see the green dot here, which means that the test passed. So let's see what that means. Let's go back to the Explorer. You can see there's already transactions going on over here. So there's one transaction out, and there's one transaction back in. So this is the account that I just generated. This is the ETH from the faucet, and this is the transaction out that will fund the transaction that is actually running the test. So let's see what that account is doing. So this is a newly generated account that Execute created for me just to run the test. So let's see how that, let's see over here. Okay, all right. So yeah, so the first transaction is just the funding again, but then it's gonna create here, over here it created a contract. What is that? So if we go back to the test, the first step in the test, as you can see, is the pre-deploy contract, and that is exactly what we are seeing over here. So the first step on the network is the contract creation, and let's see how that contract looks like. We can open up the link here, and we can see that it was created and then it was called later. But then let's focus on the code that this contract contains. So yeah, as you can see, it's the same, basically the same code that we saw earlier. Let's go back to the code and put it side by side. Yeah. All right. So yeah, this is the code that we deployed. So basically, just two push operations. This is the one over here. This is the 0 over here. The SS store is the 55 over here. And lastly, the stop. So as you can see, we deployed the contract of the test in the live running network. It doesn't end there because we need to execute the code to actually see what happens. So let's see just that. Yeah. And okay. So the contract was created, and then the next transaction is this one over here, and that one is the funding of the account. So we need a sender for the transaction, and that is how it was funded. We funded that transaction with 1 ETH only, and that is the one that is the account that it actually sends the transaction to the contract. So let's open that account, see what it looks like. All right. So yeah, it's funded, and then it called the contract. So let's see how that looks like. All right. Perfect. So yeah, as you can see, this is the transaction that is defined over here in our test. So this transaction, we set up a couple of things. So the contract address, the sender is the one that we just funded. And most importantly, you can see other properties such as the gas limit is over here. It's going to use the same gas limit, and it's also going to use the same value. So the value is over here, exactly. So it's not 1 ETH, it's 1 to the power of minus 18 ETH. So it's basically nothing. But that is what we sent over here. So yeah. The main question, I think, is how did the test pass? How do we know that it passed? So what execute does in the background is basically execute the transaction, but also go into the contract after it was executed to see this stuff, to verify this. So what we can do is actually just modify something in the code to see what it looks like when the the test doesn't pass. So let's do that just now. Let's modify. Let's say the storage. Let's set it to something else, which is not gonna match with the storage over here. And let's just send the test again to see what happens. Yep. No, it's executing again. You don't have to fill anything. It's actually the execute command takes the Python and it runs the Python lines into the live network. So the filling process is not necessary in this case. Yeah. Yeah. So yeah, the reason why it's taking a little bit is because it waits until the contract is deployed, the transaction is funded, the sender is funded. So all of that, it has to be done serially because everything has to be there for the transaction to pass. And as you can see, it already failed. It's going to tell me why in a little bit. But it first, even if the test failed, it tries to return the funds. Because imagine this is a DevNet. The ETH that we're sending doesn't matter. But let's say that we're running in Sepolia, which is a little bit more limited. So that's why even if the test failed, the execute command tries to get back the funds from all of the accounts that were involved with the test. So yeah, it's complaining right now. Basically, what it's saying is that, okay, you told me that the value of this of 0 at this address, it had to be 1, but it actually came out as 2. And this is the modification that we did over here. Yeah, so you can this way verify that the test is actually doing something and verifying stuff. So let's wait until has anybody else executed something? Did it work? All right. Yeah. Yeah, so basically it goes to the RPC and tells you, okay, how much ETH is left in the account, just subtracts the cost of the refund transaction, and then just sends everything back. That's basically it. Yeah. Let's change it up a little bit. So let's create another contract. Let's create another contract that calls into the first contract. Let's call it contract address number 1. Contract address number 2. So let's do that call. So let's make it so that the first contract calls the second contract. So yes, this call, and then address is gonna be it's gonna be the other way around. So H1, all right. And this is just to show how it can create multiple contracts in the same test. So yeah, basically the modifications that I just did is just let's create 2 contracts now instead of 1. The first one is gonna do the SS store, the same thing that we did before, and the second one is gonna call into the first contract. So it's gonna be an internal call. We should see that on Explorer if everything went all right. So let me see if I didn't make a mistake. Sorry? Yeah, of course. Yeah, that is very true. Yeah, the balance is going to be incorrect. Thank you. Perfect. All right. Yeah, let's just execute it and see how it goes. And let's see live. Let's see. Perfect. Yeah. Yeah, so there you go. So all right. So yeah, there you can see, so we are now creating 2 contracts instead of 1. So this is this account is the test coordinator. So the first thing is that it gets the funds. The second part is going to create the contracts, 2 of them this time. And lastly is going to let's see. Lastly is going to do a contract call, and the contract call is going to go into the first contract that we created. So this is 0x827. Let's see, where is that? Oh. Wait. Yeah. So yeah, let's see side by side. There you go. So yeah. So the first contract that we have is the first contract creation. This is going to do the SS store, and the second one over here is going to be the one that calls the first one that we created. So this one this one is going to call this one. So let's see, and then lastly the third transaction we're going to see is also the funding of the sender. So let's go to the funder to see how the transaction went. So because we're also going to see the contract call to the first contract. Let's see that. Let's see how it goes. Yeah, of course. So you can see right here. So the transaction is mostly the same, but what happened is that we're going into the first contract, and this first contract it made an internal call to the other contract. So you can see this right here, which is the call is done because of the call opcode that we're using on the other contract. So now you can see that the two contracts were created, and when we called into the contract, the first contract, the entry point contract, it made an internal call to the other contract. So let's see if the test passed actually. There you go, it passed. But now the verification is a little bit different, because instead of verifying the first contract, the one that is the entry point, we are verifying another contract, which is the one that's receiving the call and setting the S store over here. Yep. Was anybody else able to execute? Yep.
Shows like the back and forth transfers. It doesn't show the contract deployment, so I'm not exactly sure.
See, okay. So because there must be a contract. This one. This one is the one that is doing everything basically.
Oh, okay. It's not the key that I'm providing.
Yeah. So the key is only the key sends to the test coordinator, and the test coordinator does everything that you define in your test.
Gotcha.
Very good. So what was happening is that the transactions that we are seeing over here, they are not only the first one is sent from the private key that you are entering in the execute command. The rest go to a test coordinator, what we call it. The test coordinator is the one that creates the contracts and sends transactions. So that's why you might not be seeing the transactions in the account that you funded from the faucet. Let's see how many transactions are we seeing. So yeah, that's a lot of movement. All right, that's great. So yeah, all right. So everyone is running the tests, and luckily or unluckily, we haven't seen any deviations in the chain. So the chain is still healthy. Let's try to test, make another test, and let's try to change this thing to see if we can figure out how to break it. Yep. All right, so we already did that. Modify the simple test is basically just we can change the smart contracts, add more smart contracts, our parameterization. I didn't do that, but we can do an example in the next test, and yeah, change the expected outcomes. That's another thing that we can do. All right, so let's see a little bit on how we can test a new Ethereum feature. So what happens when we receive a new EIP and we want to test that? This is basically the work that we do when we are preparing for a new fork. So every change that goes into Ethereum happens because of an Ethereum improvement proposal. They are basically the updates that go into the fork, and that they get approved, and then we implement them, and we have to implement tests for this. This is the repository. That we can that we basically we save everything. All the EIPs come into here, and basically you can see the whole history of Ethereum over here. You can see from the very first EIP, you can see the newest EIPs for Prague and all that. Everything is here. So today we're gonna focus on an untested EIP, which is the 5920. It introduces a new opcode, and the goal here is to make a test that uses this opcode that breaks the chain. So what does this thing do? Let me just go over the EIP. It's very simple. The idea is that in Ethereum, every time that you call from a smart contract into another contract, if you want to send Ether, you have to make a call, which means that you are going to execute the code that lives in the other smart contract. So the thing that this opcode changes is that you can use this opcode to basically just send Ether to another account and do not execute anything, which is very useful if you don't want to do like re-entry in C, and you don't have to have any re-entry problems and all that stuff. This is the opcode that you eventually in the future you could use to prevent all that stuff. Just send ETH to another account. Don't execute any of the code. Yeah, normally we use call and delegate call to call the other account, send some funds into it, and just limit the amount of gas that the contract receives, just to make sure that it doesn't execute anything that it doesn't have to execute.
At this point, we can stop and see how everyone is doing, because it's happening right now.
Yeah. All right. I'm going to stop a little bit. Is there any questions so far? How's everyone doing? Questions, issues that you're seeing with the code or anything? Yes. Sorry? Sorry, I didn't.
Have we done already any other transactions, not only minting or not only minting?
No, we sent the transaction, but no, there was no minting. It was like using the faucet to get some ink.
Oh, faucet.
So, yeah, it was not minting.
It was the single transaction we sent.
It was only that.
Oh.
Yeah.
So this is with regards to the payout code. If I send Ether if I send an Ether to an contract that doesn't implement any fallbacks, does it still work, or would it revert?
So I think with this you can work around the fallbacks, because it will send ETH even if there's absolutely no code. If there's a code that reverts the transaction because it doesn't want to receive it, this would basically just skip that. So yeah, it will render some of the fallbacks unusable. That is true. So yeah, that's one of the reasons why this has not made it into the chain, because there are some edge cases that exactly what you mentioned. You can work around the fallbacks with this thing. You can already do it if you use self-destruct. You can basically send any amount of ETH to any contract, even if it doesn't want to receive ETH. Yeah. Mm-hmm. So yeah, let's proceed. So yeah, we're gonna assume that this EIP goes into Osaka. It's not the case. Osaka, as it is right now, it's only gonna introduce the EOF EIP, but we're gonna assume that it's going in Osaka anyway. So for that matter, we need to add the Osaka fork into this file for everything to work. In this case, let's see. In this specific case, we already have Osaka in our definitions, so it's not a problem. We don't have to add it. But in the case when you're implementing some EIP that goes in the future that is later than Osaka, you would need to go into this file and create the new fork. But this is not the case. It's not necessary. Osaka is already there. That's what we're going to use. All right. And lastly, since we are creating a new opcode, we need to include this in our framework. So the way we're going to do that is basically just this is the code that you need to add into the Ethereum test EVM opcode file. So let's just go ahead and do that. Again, this code is this link should be in the hackmd that was provided at the start. But otherwise, yeah, just feel free to open this link, and we're just gonna basically just copy the code. Yeah. Actually, there was an issue, and it was fixed because of that. Okay. All right. So yeah, let's go ahead. Just copy the code, and let's just put it in the EVM the EVM opcodes file. There you go. So this is the thing that we're going to use to actually use the new opcode into our code. So again, just goes to this link, copy the code, come here to the opcode.py, and inside of the class opcode, just basically just copy paste it at the end, as you can see here. I'm going to give just one moment. All right. And finally, we can write a test from scratch, but in this case, we already have a template for the simplest test that is going to use this opcode. So let me just open it up, and we can just analyze what's happening over here. Yeah. So yeah, this is basically the first test that we are going to create. This is the simplest test that you can imagine for the EIP 5920. It basically just tries to use the opcode, but the catch is that you're going to send money to the contract that executes some code. In this case, as a store, as we did in the previous tests. You remember that that's the thing that we're going to use to test storage. But you shouldn't see this change in the execution. So what should happen is that from one contract that is going to pay the other contract, it should not execute this code. So instead of writing in the post state that we should see a 1 in the key, in the 0 key, as the previous example, we're going to expect that to see nothing in here. So that would prove to us that the pay opcode sent the ETH without executing any code. So let's just do that. Let's just copy the code. And we're gonna right now paste it. Okay, I skip one bit. So yeah, in the test repository, we normally, when we are creating a new fork, we come here and create the new Osaka folder, for example, the folder for the new fork. So in this case, I've already created the folder for the file, so you can place it here. So basically, just create inside of the test Osaka folder, just create EIP 5920_pay, and inside of that, we're gonna create first the file that is required for Python to recognize there's something in here, which is the __init__.py, and it can have nothing in it. It's just gonna be there. But the other that we're gonna create is the test_pay.py, which is where we're gonna paste the new test that we're just creating. So again, a very simple test. Just use the opcode to a given recipient, verify that it doesn't execute code. We actually can just go ahead and run it. It's going to be the exact same command that we use. The only change that we're going to see is that we are going to execute this new file instead of the other file that we were using. So let's go ahead and just do it. Let's see. Okay, and another important difference is that, where is it? Okay, instead of fork Cancun, we are now actually using Osaka. And the reason is that we need to make sure that there's no compatibility issues. So we're gonna, that's the only change that we're gonna make. So fork Osaka and then also point to the new test. And let's see what happens. Let me just copy the address that we are using for this, just to follow up on the transactions. All right. Perfect. All right. So yeah, the test is currently running. It's already passed, but yeah, let me just again explain a little bit. It's basically again just creating two contracts. The one let me open up the test side by side. All right. So it's creating two contracts. The first one is going to use the S store. And this one is the one that is going to get paid. The second one is the one that uses the pay opcode to pay to the first contract. So what we should see here actually is, let's open up the contract and see what happens. Where's the value? Oh, there. I got it the other way around. So yeah. So yeah, the first contract is this one. It contains the S store. Let's see the code inside of the. Wait. Yeah. Oh. See. I think it should work, but I'm not seeing the balance change. But yeah. But the problem is that I'm not seeing that balance change here. So it should be, the balance should be 1 in here, because this is one that received the paid opcode. It might be that there's a problem with Explorer. What can we do? Yeah, we can be.
Have like a lot of issues with Explorer and we're getting lost in the cache.
Yeah, sorry. All right, let me just change the test a little bit. So what happened was that the two contracts were created, and the problem is that I'm not seeing the balance change in here. I think that it might be a problem with Explorer, that it is not updating the balance, or it might be some other issue. But what I want to do to verify that it works is maybe just change the value amount and just see that the recipient contract, it should have the balance, the new balance, which is 2. Let's see. Let's just run that again and see what happens. Oh, there you go. Also, let's see if the chain is still. It's having no problem still. All right. So yeah, basically it's working, but I'm not seeing the updates in the Explorer. It might be because it's not expecting some extra opcode that is not called to change the balance of the account. But it seems to be working here because we have this. Let's just change that to see to some other amount to see if it should fail now. Then send it again. Yeah, so now we're seeing the value that it has to be 2, and I just hard-coded 1 just to make sure that it's actually detecting the change correctly. Where's the recipient? Okay. Yeah, there you go. So yeah, it's working. It's just not in the Explorer for some reason. So yeah, I think we found a bug in the Block Scout Explorer. It's fine. Yeah, the verification is working. We're paying the contract. We saw that the test passed when we were checking for the balance that is equal to the value amount, so it was fine. And when we modified that amount, it failed. So yeah, it's working. It's just not seen in the Explorer for some reason. Yeah, we found the bug. Not the way that we wanted to find the bug, but we found the bug anyway. All right. Let me go back to the presentation. Yeah. Yeah. So with that in mind, this is like the very first step when you are testing a new EIP. You basically do the simplest test first, just to make sure that everything is working. But we can expand the testing, and we must expand the test coverage to include many other different scenarios, including edge case scenarios. That is very essential for us to see that the opcode is working before it can actually reach mainnet. Just some examples of just very simple tests that we would do if we were testing EIP 5920. Just try sending, for example, more balance than you actually have, because you're paying, yes, but if you don't have that balance, there should be an exception. What else? Try sending balance to precompiles, which is important addresses in the Ethereum blockchain. We have precompiles for many things, but just to make sure that it doesn't execute anything, with the payout code, you would try sending some ETH to that precompile. Test running without enough gas. That's a very important one, to make sure that it actually runs out of gas. It doesn't send the ETH. Try sending the balance to yourself. That's another option. And yeah, basic opcode stuff. We saw that it needs 2 parameters. Just try to do a stack underflow by just putting 1 parameter and see that it fails correctly. That's just one example. There are some things about 5920. One of them is that it doesn't specify a lot things. We normally, when we are developing the test, there are a lot of times when we read the specification and it's not clear enough. So one of those examples is how should it behave when it doesn't have enough funds. So that's one thing that we should definitely test and add to the test cases. Yeah. All right. So, but another one is that what should happen? What should happen to the account when you are already doing a call and then you use the pay opcode? You shouldn't see any difference in what is called the return buffer. So that's what we're going to do right now. We're going to write that test and see what happens. All right. So yeah, very simple. Let's do first a call. And then let's store. Perfect. All right. So let me just explain quickly what's happening here. So we have two contracts again. The first one is just basically just returning information to the first contract. All right. And the second one is calling into it. So what happens is that if we call a contract, you're gonna get what is called the return buffer. So you will see in that buffer you will see one single byte because of the return property. So what happens is that if we call and then we do the pay operation, we shouldn't see any modifications to the return buffer, right? So because we are not executing any code, there should be no reason why the return buffer is like modified or even cleared or anything. So and yeah, let's just do that. This is an opcode that is basically just gives me information about what is in the return buffer. In this case, it's gonna give me the size of the return buffer. I should see a 1 still, because I'm calling first, then I'm doing the pay operation, and there shouldn't be any modifications. So let's see what happens when I try to store that, and then yeah, let's see just what happens. And the interesting thing. All right. So the test here ideally should pass, but we already know that there's a consensus difference between the two clients. So we're gonna probably see the test pass here, but let's see what happens with the network once we execute this. It's taking longer than usual, and that might be, let's see. There you go. Perfect. All right. It's not as clear as I would like to, but you can see now that only one is following the chain. We just found the consensus bug, basically, just by trying to follow the spec, implementing the test, sending it to the network, and we can see that now, exactly, there you go. We can see the split here. This is a very simple test, and this is why we create these tests. So this doesn't happen on mainnet or even in the testnets. Yeah, one client is progressing, the other one is not agreeing with what it saw, just because one line of the opcode was different. and the result was different from what it expected. Yeah. All right. I'm just gonna continue with the presentation. Just try to wrap it up. So yeah, what we can learn from this. This shows the importance of the consensus tests. If we didn't have this, basically this could happen on the live network, on mainnet or on a testnet. We don't let it happen because we write the consensus tests. And this is the importance of the consensus test. All the clients, before they join a testnet or even a devnet, they must pass the consensus test that we create. This is very important for them to not fork out of the chain like we saw happen today. Another important part is that if a client, they are running tests, everything is passing, but they are sure that they found a bug in the client and we didn't catch it, that is feedback that has to come back to us because we have to create more tests to make sure that their edge case or their scenario is properly tested, so it doesn't happen in our client. And yeah, also specs can sometimes be underspecified. It happens. There's sometimes that when the EIP writer is thinking of the use case of the feature, they don't think of all the edge cases. So it has happened that we are implementing a test and we don't know what the outcome should be. We go back into the EIP, we improve the EIP, we specify the thing that was underspecified, and then we update the tests. So yeah, it's a running process. It's never enough until we are already tested with most of the clients. Most of the clients are passing, and that's when we are sure that that we can hit the testnets with the new feature. Yeah, One great part of having the Ethereum open ecosystem is also that tests are also verifiable. They are open, and so I encourage everyone that if you feel there's a new feature that you feel unsafe about, we encourage you to go into the tests. They are open. Everyone can verify what we're writing, what the tests that we're writing. So if you find something in the EIPs that you think that it's under tested, you can also be even eligible if the feature already hit mainnet. You can also be eligible for a bounty. So it's good to write tests. It's better to receive money to write tests. So there you go. You can use a repository. If you find something that you think is critical, one thing that you should consider is that if you trigger such an issue on a mainnet or a testnet, you're no longer eligible. So basically, if you think you found something by using your test or any other means, go to this page, but do not send a breaking transaction into any testnet, because that will make you not eligible. I think for consensus critical tests, or consensus critical issues, you can get up to 250K, which is a lot of money. So if you trigger it, you lose that. So reach out, explain us the problem, and we're going to try to make sure that the clients fix everything before making everything public. Yeah, that's basically it.
Yeah, so if you enjoyed today and enjoyed writing tests, the main message is reach out to us, and if you want to work with us, contribute with us, get in touch. But also, you can find us, if you go to the documentation, you can go to getting started, getting help, and then you can find all of our details to get in touch with us. And if you really enjoy it and you're at a bit of a loose end, then feel free to apply for the job that's on Ethereum's lever as a protocol tester. So we have a position open for execution-spec testing and consensus-spec testing. Of course. And I'm just going to show the test coverage. So if you If you want to browse for test cases, it may best to not browse the source code, but go to our documentation, make sure you're on main, and go to test case reference. Can you show me?
No, where is it?
So you can find all of our contact details here and just feel free to reach out. And otherwise, we covered a lot today in the workshop, but if you'd like to see a little bit more and a little bit of a history, then feel free to come to our talk today on stage 1 at 2:30. And if you want the POAP, just grab me. I've got the QR.
Thank you, everyone.